guest from Thailand, and today we will be present a guest lecture from Professor Dr. ChokChai Yuenyong, entitled Strategy in Physics Learning. So, first of all, I hope you remember to keep silent your mobile phone and please keep focus on the presentation because I think this is the interesting topic for us. So that's amazing. We have a guest from Konkan University, Thailand. It's very interesting for us. For your information, Professor Dr. ChokChai Yuenyong, his research area on STEM education, physics education, cultural issues in science education, special education, teaching method and teacher education. So to be more effective, please welcome Professor ChokChai Yuenyong. The floor is yours.
Okay. Good morning, everyone. And nice to come back here again. I'm very happy to come back here. My first visit here in the year 2017, and last year I come back again, and this year. Yeah. So I looking forward to come here very often. I'm a physics teacher. I used to teach in school, high school, for 4 years. Long time ago, it's probably, I think 20 years ago, I teach in high school for physics. And then I study my PhD and come back to be lecturer in university. So to me, when the first year of my physics teacher, I very nervous, because I don't know how to explain the concept of physics to students. Very difficult. I know only mathematics, communicate to mathematics, because physics and mathematics the mathematics should be the tool of physics communication, that time. But students, it seems that don't understand and say like very difficult. And the physics is not related to everyday life. Physics not good for life. We cannot apply physics in everyday life. Many questions come to me when I taught in the school for 4 years. So I'm very boring. That time I'm like tutor. Sometimes I teach from 6 a.m. in the morning until 10 a.m. by 10 p.m. 10 p.m. teaching. Because talking the same thing, how to solve the problem of physics, very early morning until very late, And I make money from tutor, as a tutorial in my country. But I'm not happy because I have no time to use the money, because after I finish the tutor, I have to go to the bed and sleep and start early morning again. That's not good, and students complain about that. So I think about it for long. How can I be better of explanation? So I go out from the school and I study in master and PhD to improve myself because I cannot explain it. I just, okay, please listen to me again. I will repeat what I'm talking. When students wonder, don't understand what you're talking about, I just say, okay, listen to me, I will talk to you again. The same thing, same word, same sentence, Students say, okay, I understand now. But I look at to their eyes. The eyes I know that they don't understand. Because they probably okay, because teacher explained 2 or 3 times already, so now I have to understand. So when I go to university and I learn the world of teaching is really worldwide, many ways to teach. One of that is this analogy. So you have to do that. So it is the art of teaching, actually. That's what I thought about that. So what can teacher do when students don't understand? Don't just repeat what you say. Okay, you have to look at to student eyes and try to get what should be the good one, good explanation. One of that is this analogy or modeling. In fact, in physics, the scientists provide analogy, provide model in the textbook already, In Thailand, we perceive only the model as a formula, F equal MA, We perceive only that model, mathematical model of explanation. We never use another thing. So can we use another thing to explain? Another thing is fit to student experience. We have to provide some explanation to fit to student experience. Okay. This one, another example. I bought this one from Professor David Tika. Do you know Professor David Tika? David from Curtin University. He wrote the book about representation. So in science, scientists know some scientific knowledge, but how to communicate to people. They use formula, they use the wording, they use picture, they use graph, they use diagram. Those things is this representation, represent to the concept, scientific concept. Here, what is it? All of you is physics? Yeah, okay. You probably explain, you probably know this thing very well. If we try to explain about the circuit, we put battery here and we put voltmeter over there, and we try to explain what happened. So what we going to explain to students? Professor David Tika showed me, we can analogy as a car moving on the road and move here, some tip over there, stolen something, and then come here. We can measure how much energy is taken by measuring the petrol difference before and after the car passed the tip. We can use this analogy to explain. It's probably makes students better understanding, but I'm not sure. I'm really hot now. Not good for me. This one. So the way of explain like the car moving here, the car, what is the meaning of the car in terms of physics? Huh? This is the first time for me to teach physics in overseas, in Indonesia, so I don't know how to say. Normally I'm talking only the research, This is the first time for me teaching physics. So What is it? The car.
Maybe in Bahasa we call it arus.
Arus.
Arus. It's a current.
Yeah, for in terms of physics. For this one, the car is represent something. Who know what the car should represent? You understand me? Now you see the picture here, the diagram here. I will not explain anything because I think this analogy is probably can communicate to you. But if you don't understand, we can change to the new one. Do you think this diagram or this picture is a good representation to this one? Do you think can we use explain that one? Who say yes? Okay, only one. Okay, only one. Very good. Why you say yes?
Okay, I think because the car is like a current in the tool, so it can be the same. That can be the way that we want to teach about the topic.
So you mean the car should represent the current, right? Yeah, the car should represent the current. And when the car, then the thief stole some energy out over there, and the car move here to take, put in the petrol, like the energy, and move again, you know, and some obstacle, something over there, like a thief stolen the energy, and the car fulfill the energy again. It's like this. I think we can explain this way to young students, but it's probably some misconception in this explanation. Do you know why? When we try to analogy and compare something, we going to say something like the car is like the current. We say like this, you know. The car is quite the same with the current. We say like this. But we have to discuss also what is this light, okay? Because it's not the same, not the same thing. When I explain this, actually in physics teaching, we try to explain like this in everyday life of teacher, but we probably say only the what is light, like the car is like the current. Yeah, okay. This is another example. This is one example, and the analogy I am going to say about analogy. Analogy make difficult and abstract concept. You know, when we say about the electricity, if we talking electricity in terms of macroscopic, we talking about the number, the current, but we can talk also in microscopic as an electron, you know, electron. This is microscopic. That way is quite abstract concept. So analogy is we have to find some analog. Can we call it some, what we call it? Analog or everyday object or experience must be familiar. We have to provide some analog. Like in that slide, I provide some car, you know, a car as analog, a car moving on the road as analog. But you have to make sure that it's familiar to students. If we say like something familiar, you know, I find some gap or do some research. We can do many kind of research about analogy because the context, different context, different thinking, different ideas. So you can provide some example or some analog, depend on your context. From Indonesia, this way of thinking, we can writing up the paper, list, the research about physics teaching from analog, because the Western people never think the same thing with us. Here I say like the science concept, okay, and unlike the concept. We have to discuss also the unlike. I just mentioned unlike. What so about that one? What is unlike? That man say something like the car, like the current. So what is unlike here? Many ladies here. I would like to ask ladies. Many ladies. This side. This. What is unlike? Who know? For this picture, do you think that you understand me? You understand my English? Okay. I will try my best to teach you. Okay. That man mentioned about this diagram, the car light, the current, right? You say like that. And I ask you, what is unlike? Unlike here. Unlike, okay, my English not good, not familiar to you, sorry. Unlike, so how to pronounce this one?
We pronounce it unlike.
Unlike, okay, very good accent. Unlike, okay, unlike, okay. Good accent. So, can you explain me what is unlike? From this, here is we call analog, you know. This we analog of the car moving on the road, and some energy lost here and move here to fulfill the energy again. Okay, the car is like the current, move here and got some energy from the voltage from the battery here, and what is current? The current should be something. When we see the current, how can we know the current? We explain as the electron moving, right? The electron moving. The electron got the energy and moving. And when the electron moving, is it current? In that way. So, who can tell me what is unlike for this one? Yeah, now we tell, okay, the car is like the current, and the energy is something moving the car. It's like the voltage here, you know. So the energy is like the voltage to moving the car. Okay, may I ask someone to tell me about unlike? Okay, you have eye contact. You very good eye contact to me. I think you have some idea. Just tell me something that you think.
May I
Okay.
translate it? Mr. ChokChai said, apa yang berbeda dari representasi yang di samping kiri dan sebelah kanan? What's the difference? Apa bedanya? Apakah ada perbedaan yang sebenarnya disama-samakan seperti itu? Tadi ada mobil bergerak, apakah itu betul-betul bisa merepresentasikan arus gitu? Nah, kayak gitu maksudnya. Mungkin bisa dijelaskan.
Ya, kalau pakai bahasa Indonesia ya. Ya.
Indonesia bahasa.
Yes.
Java is okay.
Yeah. Last night he talked Java with me.
mobil itu menganalogikan sebagai arus. Yang membedakan itu PD-nya itu sebagai V. Ya.
Japanese or Bahasa?
Bahasa. Contohnya bahasa. Okay, thank you.
So, can
Maybe can repeat your answer, please.
The unlike is the PD. The PD.
Oh.
Yeah.
Or he said that the unlike for this one, the V and the PD. PD.
Oh,
V from
yeah.
it's different.
PD.
She said it.
Yeah.
Petrol, different.
Petrol difference.
Yeah. Petrol and volt.
Yeah.
Yeah.
And the volt.
Okay. Something else? Something else? And I think the different thing is the electron move very fast, but the car not fast like that. You know, the car is not fast like that, but electron move very fast. This is the different. You know, the different. Do you agree with that? So something else to different. Yeah, we have to discuss like this. On the way we discuss what is light, what unlike, what is different. This is the kind of what we explain about the physics phenomena. You know, you understand me? Normally we explain for formula and solve the problem that it's not a concept meaning of concept, physics concept. Okay. Don't worry, I will ask you to develop this kind of analogy for some concept. I will ask you, well, because I have 2 hours, so I cannot speak alone for 2 hours. I will ask you to speak to me for 1 hour, you know? This is a teacher, so teacher have to ask student talk to teacher also. And here, what I talking? So, analogy, sometimes I talking this one, so the analogy should not too far or too literally. So, I mean too far is from student experience, you have to think what is should be good for student to understand. Okay? You understand my English? Okay? You understand my English? And I will move to another slide. Here, analogy is we provide some analog. It's a car moving on the road, and we have petrol as a voltage. The car is an electron or current, you know, and energy is the petrol. Okay, we try to explain that. So we have to discuss to the student about the diagram or the analogy, analog. Okay. Analog means something from the object, everyday life object, or experience, or some simulation, or some computer simulation. It can be analog. Okay. So I will ask you about the conduction of heat. What is the conduction of heat? And what and how will teacher explain about conduct of heat to secondary school students? Okay? This is my question. To waiting for your response. I will ask you because I don't know. Now I never teach physics for 20 years. You know, 20 years ago, I was physics teacher in the high school, but now I teach in university. I teach research, and philosophy. So I forgot. What is it? Okay, this side. What is conduction of heat?
Yes. Ada yang bisa jelaskan apa itu konduksi? What is conduction of heat? Anybody? Please. From the right side. Okay, don't be shy. Anyone could give a statement about conduction of heat? Maybe you can direct someone. Oh, you're very busy. For you, what is conduction of heat?
Can you explain any two line, you know, your idea?
Jadi konduksi itu merupakan perambatan panas yang tanpa melalui perantara muatan-muatannya.
Conduction is the heat flow with material.
The heat flow.
Heat flow.
Yeah. How can we know the heat flow? How can explain the heat flow to student?
Bagaimana?
How can we explain the heat flow to student? Because we never see the heat. Okay? You never see what is the heat look like. Handsome or beautiful, we never see. How can we explain to student the heat flow? Okay.
Mungkin dengan cara perubahan suhunya kita bisa mengamati terjadinya konduksi itu.
She said that by measuring the difference of temperature.
So good, you very good concept of heat, you know. So we have to find some level of heat. Is this temperature, right? The temperature is the level of heat. In Thailand, we quite confused about heat because we normally say the cool subject, the cold subject, and the hot subject. So this is the wording in everyday life. But for the scientific word, is we call temperature, low temperature and high temperature. So the heat flow, you know, and you have to provide like some experiment to check where is the low temperature, where is the high temperature. I'm still quite wondering. You say the heat moving, the heat flow, you know. So it means you have to take time waiting for the heat moving to go somewhere, you know, and you have to check on the initial state of the temperature and then waiting for a while to allow the heat moving to somewhere. So what should be explained? We have to provide some context or some situation, some experiment, so that why scientific teaching, we normally do some experiment. So experiment is just another analogy to understand the concept, you know. In Thailand, we teacher quite perceive that okay, teaching science, do some experiment. But in fact, there are many ways to explain, not only experiment, but experiment is the best, but it's not only that one. Okay, if you instantly heat the end of the, you hold the steel, the copper, the aluminum rod, and you have to measure the temperature, the rate of heat travel. Okay, you see about the heat flow, right? The heat travel along the steel and copper and aluminum. When you hold the end of wooden and the piece of wire in the candle frame, we have the fire on the top and we hold on the end of another side. Why you will quickly drop the wire, but you can hold the wooden stick, even it's on fire. You understand? We hold the wire and the wood on the fire, but you drop very quickly for the wire. Okay. What happened? What happened to you? Quiet again. I think so. You know, I don't know. You understand me or not? You know, because you keep quiet. So that's why I'm trying to. What happened? Why like that? Okay, you answered me already. I have to move to another one. Okay. Why we have to drop the wire very quickly?
Menurut saya, kenapa kawat ketika dipanaskan harus kita lepaskan lebih cepat? Karena perambatannya, karena panas lebih cepat merambat di kawat. Karena bahan dari kawat itu merupakan konduktor dan kayu itu merupakan isolator.
Okay, the conclusion is the wire is conductive, has a high conductive than the wooden. So in the wire, the heat flow rapidly and faster than in the wood, like that.
Okay. So the heat is moving faster than in the wood?
Than the wood, yeah.
Okay, good. But why is faster? Can you explain me? Why is the heat is moving faster on the wire, but the wood is very slow compared to the wire? Move to another one. Move to another one.
The other one, please. Okay, for you. Kenapa besi lebih cepat merambatkan panas?
Jadi kalau menurut saya partikel atau materi dalam aluminium itu lebih padat daripada di kayu. Mungkin seperti itu.
Yeah, like that. She talk about the space with interatom in wire is closer than in the wood, like that. Based on the microscopic view. Yeah.
On the microscopic. Now we need to demonstration to students. What is the demonstration? What is the microscopic working for explanation? You know? Sometimes we explain in macroscopic, but sometimes we explain in microscopic. Oh, the word is confusing to students. You know, the student is probably confusing something like that, but they never tell you. You know, the teacher have to worry about this when we explain. Oh, I learned that everyone here very good concept of physics. You know, can explain me about the phenomena. So, how does a metal conduct heat and why would bad conduct heat? You know, so in the everyday life word is a bad conducting, bad heat trans, bad heat moving. Oh, based on your explanation, you know, based on your explanation, I will do some movie of the heat on the atom because heat, the heat is flow. We never see the heat. We see something moving, like when we boiling the water, the heat in there, but we never see the heat. We see only the molecule or atom of water is moving around. You know, okay, this is the energy moving already. So sometimes the heat is like the growth. We or the something we never see it, you know, but it should be something in there we call energy, but we never see energy. We see energy only when when it moves, and we see something shake or moving around. So here is my house. Here is my house. I take photo many years ago. Here is my physics book. When I taught in the high school, very old book, and now I will never teach physics again in high school. So I have just talking about you talking about some molecule from atom of the wood and why is different. That way of explanation. So what we going to do about this? So you're talking about. So I think we can provide a book. You see here is quite a big space here on the book, but here is very close. You see. So what should I do? If you say like that, I provide you the book and the domino here to explain about why is the heat is travel on the metal faster than on the wood. Okay, can you help me to provide the book on here, the book and some small thing.
Anyone who want to be a volunteer?
Variable. Because here 1, 2, 3, 4 here. Here. And the same level. Yeah. how can we show students? This one, the heat move faster. This one is slower. This one is, as you mentioned, about the atom is very close. You see the gap here, very small gap. Here is big gap, you know, big gap. So you can, because if some move way down here, it can So we go to explain to explanation here. The heat moving is like the book laid down, you know. We can see the heat when the book is laid down here. And we can understand which one is faster, heat moving. When this one is laid down very fast, it's probably the heat travel very fast, okay? If this one is slower, he's very slow. So we have to come here, you come here and push at the same time. I need the camera, the slow motion for iPhone or something. Okay. Well, I will take So how can we do? We do the same time? Yeah. The same. Go to a hand. Okay. Whoa. So what do you see? This one is the partial. The book is okay. Show it again and you also record. Very nice shot. Very nice shot. Yeah. Because on your video very nice shot. Okay. Do experiment again. For the slow motion, you see the book very slow, way down, and the small one is very fast. In front, because I very low Yeah, show on the, yeah. Good to do it again. Do a great one. Okay. One, two, three. Only 3 seconds.
more luminous. Sama ya. Jumlahnya sama. Jumlahnya sama. Jumlahnya sama-sama nyenggol partikel yang lainnya. Ini jumlahnya. Bisa dimulai lagi yang
Because of the explanation, I can't find some answer to give to my parents. I need to class. So teacher try to provide something and just ask students to share the idea. And here we come up with an explanation, analogy. So you probably talk about something moving is kinetic theory, and particle idea. You talking about particle is like atom, molecule, and the book represent atom or molecule make up the metal and wood, and domino represent electron that are free to move around in metal, but not free to move in the wood or plastic. Yeah. Because in the microscopic explanation, we see the electron for the metal moving around. So here we're gonna to teach about analogy. Professor Richard Cole, actually he is my lecturer. My teacher when I studied in New Zealand, Professor Richard Cole. I learned from him a lot, and he wrote a book about far guy with his friend. So here is the far guy for teaching analogy. As I discussed to you, when we provide some analogy, normally we provide only something the same, but we never explain something different. Then we try to provide some analog. We talking about what is the same thing, but we never talking about what is different. So this guy, I mean FAR guy, is probably suggest you to develop learning activity. So the F is standby focus. So it's be sure of what your student know and why you want to use the analogy. I use the car and I use the book and domino here. I think everyone probably really obvious observe, you know. Action, be sure check that your student understand everyday life object experience you plan to use, and make sure you always discuss how analogy is live and unlike the concept. Here, to make sure students understand this, so I ask students to share the idea. It's not my idea, it's idea from student, so it's quite sure that it's familiar for another. And we have to reflect also, okay, here. Do I need to revisit this explanation in a better way to use analogy next time? So it's kind of assessment. Reflect ourselves. Is this good enough for focus and action about? I think the keyword here, what can you find, what is you going to focus, analogy, and what you action about. So the action, it should be live and unlive. That's good. The theory just here and here. Focus, action, and live and unlive. But here is after the class. I will show you the more detail about this. Because too many explanations, so I provide in the word. Here, domino and the book analogy for conduction of heat. Focus concept of conduction of heat rely on particle. Student can visualize solid as closed particle. Oh, what is? For probably something mistake. Each author transmit heat energy from one particle to another. Here is concept we're going to teach, and students are familiar with line of people. Each author, the material are good or poor conductor of heat. Analog is line of domino, and the book sort of line domino of falling in line. So the domino and the book falling down. We have also mapping here. Analog domino, target. Analog domino. Domino standing up that can fall over, and here is compared to target. Target is mean the concept. Concept we're going to explain. Here analog is domino and the book. The target is concept of physics. So domino is free electron that can move around. The book falling over is the atom and molecule that vibrate. Atom and molecule vibrate. Domino falling over quickly is free electron speeding up when heat is absorbed and moving around, bumping auto. You see, here we compare light. You see, analog mentioned something, and this is the concept. Here, fast falling domino is moving good heat conductor compared to poor one. slow falling books is in non-conductor having only vibrating atom and molecule. And we also provide allied. Allied here. Yeah. We have to discuss also allied. There are many more electron atoms than domino. To compare, the book and domino is only some, but electron, many electrons. Domino and book fall one, but only one way. Domino and the book only falling down on one way, but electron, many vibrate continuously many times, here, and all direction all the time. This is atom and electron. And different size between electrons, atom is much greater than size difference between domino and book. I mean, electron is very small. It's like the grain of the light, the grain of the light, one light in the soccer field. The soccer field is probably atom, but electron is very small, like the grain light. Okay, you understand? Very small. Okay, that one. But here is the book and the domino. It's not a big difference like that. It's not big difference. This is not the same. So we just compare something. So then we can conclude that heat wave because they have free electron. Okay, now because they move, the heat transfer very fast because we have free electron like this. You can imagine if the electron very small, smaller than the domino. It's probably very fast, Even domino here is very fast, faster than the book, Yeah, you can see from the video. The domino move very fast. If electron is probably very fast, very fast. Okay, here is just one example of explanation. Quite easy. But you have to provide some compare like this before you go to the class, and you will have some explanation that's probably easy to follow. If you provide like something here, you got something to ask student. Okay. Now it's time for assessment. Time for assessment. I will ask you, your friend beside you, next to you, talk to you, each other, and looking for some scientific concept, some physics concept, and looking for some analog. You understand analog? Yeah. Analog is here is a book and domino like this, and or even drawing something. So sometimes it means some object can be analog. Some situation, some experience can be analog. Okay. You may call each other. I will give you how long to think about it, and I will ask you to present what is your analog and what is your idea about different words. Show them. Like here. Can you show me this one? Here, the action. I think this is the important thing, the action. Here. Okay? You provide analog and the action. And unlike is quite small thing that you can think later. But here, will be good. I think 10 minutes. 10 minutes because we have short time now. 10 minutes.
Saudara-saudara, kalau hari ini VAR yang Anda kembangkan, yang cara bagaimana mengembangkan analogi ya dari gejala fisika, kemudian dibuat analoginya yang lebih mudah untuk siswa. Kalau pagi ini belum selesai, bisa Anda kerjakan di rumah dengan pasangannya, nanti ditulis ya, dijelaskan dengan format seperti tadi, ada fokus, ada action, ada reflection ya. Ada action, ada reflection. Seperti format ini ditulis, mungkin bila perlu dibuat diagramnya yang actionnya kayak apa itu. Tadi seperti ini, tadi kan di video kan slow motion bisa kelihatan bedanya. Nah itu, tolong itu dikerjakan di rumah. Kalau sudah jadi lengkap dengan penjelasan VAR-nya, focus, action, reflection, ya, beri penjelasan di format itu seperti contohnya tadi dalam bahasa Indonesia yang rapi. Kemudian buat satu lagi translate ke Inggris dan itu dikumpulkan. Kami ingin mengkaji cara pandangnya mahasiswa Indonesia dengan mahasiswa Thailand itu konteksnya bagaimana, persamaannya bagaimana, bedanya seperti apa ya. Jadi kami ingin mengkaji itu berdua, kami Pak ChokChai dan saya ingin tahu cara pandang, cara pikir Anda sebagai guru fisika membuat analogi untuk menjelaskan gejala yang sulit menjadi mudah bagi anak-anak ya. Paham ya? Jadi nanti kita nanti tentukan apa Anda perlu 2-3 hari untuk menyelesaikan ini, terus nanti dikumpulkan ke saya ya. Berpasangan ya, berpasangan tidak sendiri-sendiri. Mikirnya lebih mudah kalau berpasangan ya. Jadi bisa berdiskusi. Cukup jelas tugasnya ya. Ya, saya kira some question you can ask me and I will answer your question in bahasa Jawa. Ya, ya. Yesterday, Professor ChokChai asked me about several Javanese language or word actually, and then he learned how to pronounce Javanese word from me, yeah. And I learned Thai language from him, ya. Jadi oke. Oke, ya. Oke. Selanjutnya silakan ditampilkan ya.
Professor ChokChai choose two group for present. The first for heat and concept, you, and the second for the magnet force. Please come forward to present your work, please. Okay, give applause for our friends. Come on, come on. And you for the magnet force, please. Both of you, please. Okay, come forward, please. Okay. Okay, for the two groups, please come forward. Then present your analogy, the like and unlike analogy with the concept. For the first, please hit and concept first. Okay, please.
English or Indonesia? Indonesia. Or how? Try to speak English first.
Assalamualaikum warahmatullahi wabarakatuh. In here my group will present about my idea in analogy about in one of physics content, that is heat transfer. Like we know, heat transfer, we as student, maybe as teacher, we understand about heat, but students don't know about heat. Maybe we understand the concept about heat, but when we first introduce it to students, they don't know what is heat. They don't see heat. Because of that, it will be a little bit difficult to students to understand it at the first time. And our idea to make our learning in heat transfer easier is the idea about two containers that have the first container contains water, the other container contains no water, and between two of them we make a hole that we can close and open like that. And also we provide a pipe that can transfer the water from the first container to the other container like that. Like we know, heat can transfer from if there is the temperature difference. Heat can transfer if there is temperature difference. And in our analogy, the water can move from the first container to the other container if there is pressure difference between two of them. So the first container, like the picture is so small here. So is anybody can see it now? Yeah, maybe the whiteboard is on.
It's better you take a picture of your note and then
Okay. Hello. Okay. Everybody is still with me? Okay. The first picture in our sheet in here, we have two containers. So we describe the heat transfer, thermal contact and other through this. So we have two containers. The first is full of water and the other is empty. And in the bottom of the container we have a hole that we can close and open, as I said earlier. Then in here we connected two containers with pipe. When we connected two containers with pipe, the water from the first container will flow to the other container. The flow will happen as long as the height difference between two container is still in there. So, jadi alirannya ini akan terus terjadi selama ada perbedaan ketinggian gitu. And the flow will stop when the height of the water between two container is same, like that. The concept between this, our analogy with the heat concept is the first heat transfer happen when saat kita dekatkan gitu loh. Jadi transfer kalor itu terjadi saat ada kontak termal gitu kan. Jadi heat transfer happen when we make thermal contact between the two of object. Nah, kalau di sini dia terjadi aliran jika kita hubungkan dengan pipa. Jadi menghubungkan pipa itu adalah representasi dari kontak termalnya. Are you still up? Are you understand? Do you understand? Okay. and then the first concept is about contact thermal, and then the second, heat transfer happen if there is temperature change, temperature difference between two objects. In our analogy, the flow of the water is happen because there is a different pressure between the two container. In here we write the formula. In here the pressure in the bottom of the container is the pressure of the atmosphere plus rho GH. And in the other container, the pressure in the bottom of the container is just the pressure of the atmosphere. So there is the difference, that there is pressure difference in here, so the water will flow from the first container to the other container. And we just found that beside to explain the heat transfer, we just also found that we can explain the conduction of heat from this analogy too, by seeing the pipe in here. We know that heat transfer, the rate of heat transfer Q per T is equals to K times A times delta T per L. So in here we know that it is linear with the area, and inversely with the length of the pipe. So semakin besar pipanya kan semakin cepat kalornya gitu. Jadi the greater the area of the pipe, then the greater the energy transfer happen. Then semakin panjang pipanya semakin lambat, semakin lama waktu yang dibutuhkan. Sama juga seperti ini. Jadi semakin panjang pipanya semakin lama waktu yang dibutuhkan. Semakin panjang penghubung antara dua objek yang terjadi transfer kalor tadi, maka semakin lama juga waktu yang dibutuhkan. Like that. Okay. Do you understand? No. Thank you. That's all from my team.
May I ask some questions? You got to teach the heat conducting heat transfer, and you will present what is the water in there. Here is water. Water here, and the student have to compare something. What is the light and unlight? What is the analog and the target? Can you show me some example? Analog and target, something like the level of the water and the pressure or something. Here, in theory, the first time is like this, and then move to here in another side, right? So here is analog. So what is target of this situation?
idea in this lecture ya. Okay, ya.
Okay, thank you.
Yeah, next.
Next one.
Yeah.
This one for
Magnetic, ya, magnetic.
Oh, yeah.
Yes.
Oh, see.
Another group. Yes.
Okay.
Another pair. Silakan.
Assalamualaikum warahmatullahi wabarakatuh. Here we will present our discussion. We use magnetic force as, and the analogy is between the boys and girls. You know that when boys meet the girl, they will tertarik satu sama lain. Ya pokoknya saling tertarik satu sama lain kan. Kalau cewek ketemu cewek kan jarang untuk saling tertarik gitu. Jadi di sini kita mengibaratkan kayak ya ini sering sih, udah sering dianalogikan sama biasanya guru-guru fisika. Itu kalau cewek misalnya kutub utaranya, cowok itu kutub selatannya. Jadi ketika kutub utara bertemu dengan kutub selatan, dia kan bakal tarik menarik. Sedangkan kalau kutub utara ketemu utara kan tolak menolak, seperti itu.
Kan tadi contohnya kalau dari Profesor ChokChai ada gejala fisika itu apa? Yang Anda maksudkan di sini kan magnet ya?
Ya.
Tarik menarik magnet itu. Kemudian analoginya kalau tadi konduksi antara barang yang konduksinya baik sama konduksinya jelek itu tadi digambarkan gerakan buku sama gerakan apa tadi domino atau kayu kecil tadi. Begitu jumlahnya sama, ditekan bersama-sama, yang kecil lebih cepat roboh seluruhnya dibandingkan dengan buku. Nah itu analoginya. Nah yang ini yang Anda lakukan apa analoginya?
Misalkan mungkin kalau apa perempuan itu apa lebih
nah itu yang perlu sesuatu untuk anak SMA ya. Anak SMA itu hal yang real, yang konkret bisa diamati sehingga mudah dijelaskan. Ya ya. That's I gave explanation to them about analogy. So you have to think something real, ya. Jadi yang dianalogikan itu sesuatu yang kasat mata bisa dilihat. Seperti tadi itu yang satu lebih cepat, satunya lambat untuk membedakan. Satunya konduksinya baik, satunya konduksinya jelek. Ya, nah itu yang that is the analogy that you have to try to explain to us. Ya, pada kita semua ya. Oke, that's sudah itu. Oke. Ya. Next time better ya.
Yeah, I think it's a quite good context about boy and girl. So they need to compare like and unlike.
Yeah. But for senior high school student, we need something real to can be observed, like your example. So, like the first group try to explain the heat transfer using fluid mechanism.
Yeah, I think when you present here, I thinking about what kind of activity, what kind of experience that familiar to students. It should be something in the Indonesia context. It would be good. In this way, you not only create a new thing, but you provide some example to the Western people also. If you show some idea from Indonesia, like when I was young, in Thai textbook, we provide some analogy like the pancake. The pancake like atom, so is electron is separate in the pancake. You know, when I was young, I studied physics in the rural area. The food in my area very different in the Western style. So I have no idea about that. I don't understand the pancake, you know, because I'm very from the rural area. I don't know what is it. But lucky on me, I have chance to study in New Zealand. I eat pancake every day after that, you know. Oh, no, now I know what is it, you know.
What is the real pancake?
Yeah. So now I know already. Here is the atom, you know. I learned from a textbook, but I never eat it, you know. So that way of explanation is not good to the local student. So we have to looking for some example to fit to our context. So we have to strong conception of physics and strong concept of everyday life in Indonesia or in Thailand, you know. So it's like the two worlds, the world of physics and the world of everyday life experience. You know, I teach in Thailand. I found many different worlds. The world of physics and the world of everyday life. Something we talk the same word in Thai, but different meaning in physics. I cannot explain here, you know. in my area, we talking about the gravitational potential energy. But in my language, in Khon area, the Isan dialect, different in Bangkok. The term of potential energy is show us some behavior like in different way, different words, different meaning. So students can misunderstanding about that. So we have to find some issue in our language or our everyday life to discuss in terms of physics here. If you can do that, it's very good, because I think is no one try to explain from the content. I think in ASEAN country, many book is provided from the Western. So many example is Western idea sometimes. But the world now is quite globalization. Everything is the same already, but still have something different. Still have something confusing us, like me when I was young. I don't understand. I don't understand the velocity. You know, because that time I don't understand the kilometer per hour. You know, velocity. Because I never know this idea, because that time I walking to the school, no car, no motorcycle. That time, very poor area. I study very poor area. So I go to the school and teacher talking velocity. What is it? I know only the distance and the time, but for velocity is in the air. Nothing, you know, because velocity is this distance per divide by time, you know, and the accelerator is divide again by time. You know. Still never know about that. Cannot imagine anything. So how can we teach the abstract concept? But any concept of physics is abstract, you know. we have to carefully think about it because some students don't understand. But for me, I'm very lucky that time representation in physics, only mathematics. So I can survive myself because I solve the problem through the formula. But I don't understand. I just remember some formula and try to solve the exercise. Okay. Not good. So I hope that you can provide some context there, okay? From analogy. So, okay, I'm on time. I finished on time. Hope to can develop further your homework. I give you homework now, and you probably send to your professor. Yeah. You want to say something? Or?
Yeah. I will say in bahasa Indonesia, oke. Saudara-saudara, pelajaran baik dari Pak ChokChai bahwa siswa kita itu, jadi Anda sebagai guru jangan berpikiran murid-murid Anda seperti diri Anda. Pak ChokChai cerita murid desa itu waktu dia kecil mengerti kecepatan aja nggak ngerti itu binatang apa kecepatan itu. Yang dia tahu hanya jarak dan waktu. Kecepatan itu kan jarak dibagi waktu. Itu bagi anak kecil, mungkin anak SMP itu juga anak SMA barangkali juga istilah kecepatan itu sesuatu yang abstrak. Sehingga dengan menggunakan analogi ini Anda bisa menggunakan hal-hal sehari-hari yang ditemui anak itu digunakan menjelaskan konsep-konsep fisika yang abstrak. Nah itu jadi kalau Anda menggunakan VAR ini focus, action, dan reflection itu ada dua hal yang harus dijelaskan. Yang satu berkenaan dengan gejala fisisnya, yang kedua analoginya apa itu yang padanannya. Padanan itu diambil dari kejadian sehari-hari yang biasa ditemui oleh anak-anak. Sehari-hari dihadapi oleh anak-anak. Nah, itu yang di-PR-kan pada Anda semua. Pak ChokChai tadi minta saya nagih ya. Nanti karena ada rencana kami untuk kami compare, kami bandingkan dengan siswa calon guru Thailand ya. Pola pikirnya apa sejenis atau mungkin berbeda dengan konteks budaya yang berbeda. Mohon VAR ini nanti di saya sudah dikirimi oleh Pak ChokChai format yang harus diisi, yang hasil diskusi Anda dengan pasangan diisi. Nanti saya bagikan mungkin lewat ya semua yang hadir ini nanti buat, mungkin diberi waktu berapa, seminggu cukup untuk membuat itu ya. Utamakan yang bahasa Indonesia dulu. Kalau itu sudah jadi, nah nanti bahasa Inggrisnya minta tolong Mbah Google. Tapi kalau ada aslinya yang bahasa Indonesia, saya bisa ikut memperbaiki bahasa Inggris Anda. Ya, jadi saya akan buat yang bahasa Inggris, saya revisi, hasilnya nanti saya serahkan ke Pak Chok. I will send the result to you, and we can make a comparison there. Oke, itu ya. Jadi seminggu. Jadi kuliah tamu ini ada manfaatnya. Anda belajar tentang analogi dan coba belajar. Kalau analogi itu baik dikumpulkan dari semua nanti, itu bisa menjadi alat ngajar Anda untuk menjelaskan konsep-konsep yang sulit, yang abstrak menjadi sesuatu yang mudah. Harapannya begitu, menjadi gampang. Ya. Jadi itu saya kira kesimpulan yang bisa kita peroleh dari sini. Moga-moga ini bermanfaat bagi Anda semua, menambah wawasan tentang pengajaran sains atau belajar fisika, ya. Oke? I think that's all for today. Oke. Oh ya, Pak ChokChai minta foto bersama di sini ya. Jadi itu juga nanti jadi kenangan juga bahwa ini loh mahasiswa Indonesia ya, dengan Pak ChokChai di sini. Ya, iya, gitu ya. Oke, mari silakan. Oke ya, ini backdrop ya. Silakan, Pak.
Okay, please come forward to take a picture with Professor ChokChai. Come on, please, hurry up, please. Come on. Nggak kelihatan mas kalau situ. Ambil tempatnya.